Okay, so not that I'm bitter and twisted, of course. Yeah. Yeah. Oh, well, yeah, I am. Okay. Yeah. So, have you three been drinking or something? What is going on? So I feel like I'm drunk, but for a different reason. Okay, so I'm going to be talking today about making the database relevant again. Hands up, how many people here are Oracle people? Do Oracle development? Awesome. How many people know anything about ORDS? Oracle REST Data Services? Good, good. Okay. So it's good when not many people put their hands up because it means I'm saying something possibly new to you, which is a good thing. Your worst fear is everyone goes, yes, I'm a well-renowned expert at it, and then you sort of feel a bit dumb standing up the front talking about it. Okay. So let's get started. My name's Tim. I've been working with Oracle Tech for about 23 years. I've never worked for Oracle. I've always been independent of them, which means I can tell the truth, which is nice. I have a website, oraclebase.com, which I've been doing for about 18 years in July, I think it is. And that's what I do when I get home from work. It's just something I do in my spare time. So if you've come across that and you liked it, that's cool. If you hated it, he did it. As a result of that, I got invited onto the Oracle ACE program about 12 years ago. And I've been really lucky and got to go around the world talking about tech, which is pretty cool. And about just over a year ago, I think, I got invited to the Oracle Dev Champion program, which is kind of scary because they make you do lots of things that you're no good at. But that's all right. The agenda for today, sort of brief introduction to some of the tech we're going to talk about. I'll throw a demo in there as well because I think the demo is kind of nice to show how simple this can be. And talk about some of the features of JSON support in the database and ORDS as well. All the slides, PDF, the slides themselves, and an article you can get to from that URL /workshops, but I'll show you that later as well, so don't worry. Okay, so what's the point? Well, I could have been doing, well, in fact, I did do this sort of talk over a decade ago, but then I was talking about web services from the database using XML, so typically doing something like SOAP or REST web services using XML. The attitude is still the same, but obviously the world has moved on. So the situation is, and has been for some time, a lot of people consider relational databases legacy. There'll be a lot of people at this conference, because it isn't a straight Oracle conference, that will not be interested in relational databases at all because they're something that granddads do rather than, cool kids. As a result, my primary programming skill, although I've done lots of languages over the years and still do, the main thing I think I'm pretty good at is PLSQL. And as a result of relational databases being legacy, then one of my main programming skills is also considered legacy. So what do I do about that? Well, one of the ways I think you can keep yourself looking relevant is to try and package what you do into a form that other people find useful and interesting. And one of the ways of doing that is to present your stuff to the outside world as REST web services. And that's what we're going to talk about today. So there's nothing new here. Like I say, I was doing talks 10 years ago like this, but it was all using XML then, and now it's all about RESTful web services using JSON. So what's JSON? This is probably the simplest quote I've found. There are lots of quotes, but I like this one, and I'm going to read it out because I think it's really neat. JSON is a syntax for serializing objects, arrays, numbers, strings, booleans, and null. It's based on JavaScript syntax, but it's distinct from it. Some JavaScript is not JSON, and some JSON is not JavaScript. So loads of quotes all over the net about what it is, but I really like that one. It's about as simple as I could find. So really three basic elements that make up JSON. We've got name-value pairs. That's our sort of core JSON data. The name is typically a string in double quotes, and the value can be a variety of things, including objects, arrays, numbers, etc. We also have a JSON object, which is a comma-separated list in curly brackets, curly braces. And in there, you can have a series of name-value pairs, and importantly, the values can be of different types. So not every value has to be of the same type. In this example, we have a numeric and a string. We also have JSON arrays. An array is a comma-separated list of stuff surrounded by square brackets. Now in this case, because I'm a database guy, I typically end up processing arrays full of very similar stuff. So in this case, they're employee records. But the important thing to remember is that these don't all have to be of the same object type. They can be completely different. So I could have just a string, a JSON object, I could have a nested JSON array in there, and that's all totally fine. So that's effectively JSON. But the same way that XML can represent relational data, so can JSON, and we'll see some examples of that as we go along. Why is it important? Well, as we were all having this fight over whether Java was better than C# or vice versa, JavaScript sort of came in and killed us all. So JavaScript is a really important language, and JSON and JavaScript work really well together because you can take some JSON data and easily parse it into a JSON object, because with some caveats, JSON pretty much describes JavaScript objects. And vice versa, you can take a JavaScript object and convert it to JSON really easily. And that means whenever you want to persist something from JavaScript, it's really easy to turn it into something flat and send it across the internet. So if you're not interested in JavaScript, then it's still useful to us. Why? Because we can think of JSON as skinny XML. It doesn't matter if you can't read this, it's the message that's important. So imagine we've got some XML that is describing, in this case, a single department, but that could be a department list with each department having its own employees listed, nested into the structure. And then the equivalent of JSON. So they look pretty similar, pretty easy to read, both of them. This is probably a little easier to read because it hasn't got those nasty tags. And what we can see from a size perspective is that the JSON is significantly smaller. Now you might be saying to yourself, well, that's really cheating because I can make my XML a lot thinner. That's tag-based. What if I went for attribute-based XML? And sure enough, that's smaller, but not as small as the JSON. So JSON's pretty important when we're talking about transfers of information. It's never going to be as thin as something like CSV, but who wants to be passing CSV around? It's a nightmare. But it's certainly a lot leaner than XML. So it's interesting from a data transfer perspective. And when we think about what we're doing with web services, it's all about data transfer of some description. So JSON's pretty interesting from that perspective. What's REST? This is what I've been doing almost entirely since I got to Latvia. Apart from when I've been standing in front of people. So, and possibly what I'll do as soon as this finishes as well. So REST stands for that, which I'm not going to read because I'll get it wrong. The important thing about REST is it doesn't have very many rules. There's no formal, you must do this, you must not do this in terms of content, although some companies would have you believe there are sort of fixed rules. But the most important thing is that when you look at an individual URI, it doesn't determine what the action is going to be. So, for example, having something like WSHR employees or employee is totally fine. But having delete employees is not, because then that becomes remote procedure call. Okay? So we shouldn't know what the action with that resource is going to be based on the URL. Instead, what we've got is HTTP methods. Now, there's more than this, but these are the ones we'll commonly use, which are get to return some information, post to create a new resource, put to amend a resource, or if it's not there already to create it is a typical use for that, and then delete is to remove a resource. Those could be mapped to individual statements, but I don't particularly like that, and we'll come on to that later. So, in my opinion, what you should be doing is presenting logical units of work to the outside world. Most developers, especially if they're not from a relational background, don't really give a monkeys if you've got like 50 tables that represent an employee. They just want an object that creates an employee or amends an employee. So it's important that you present out logical units of work, not individual tables. Individual tables are kind of ugly, and we'll see why as we go on. And as I said before, REST itself doesn't dictate formats. It doesn't even dictate protocols. If you look at the original REST documents, they showed examples of using FTP to do REST. So protocol isn't really important either, but we've kind of, when we talk about REST, we assume you mean HTTP and we assume you mean JSON most of the time now. Okay, so what's ORDS? Well, has anyone used Apex before? Oracle's Application Express? Okay, quite a few people. So back in the day, we had this thing called mod PLSQL, which was an Apache mod that sat in front of the database, allowing database calls to be routed, allowing URLs to call database functionality and pass information out. What happened a little while ago, a few years ago now, was that functionality got rewritten into a thing called the Apex Listener, which is a little piece of Java war file, and run either in standalone mode on Tomcat, WebLogic, or Glassfish. And essentially, it was a replacement for mod PLSQL. That's how it started, but then it got a lot more functionality as time went on. So what you would have seen in the early days is something like an Apex architecture that looked like this: database with metadata in there and the runtime engine for Apex in there, and some form of gateway sitting in front of it to present it to the outside world. Used to be mod PLSQL, then we got the option of embedded PLSQL gateway when we were demoing, and now typically you'd expect that to be ORDS because ORDS is a lot better. So in addition to the Apex listener functionality, it got some other stuff, and that's when it got rebranded as Oracle REST Data Services. So essentially what we've got now is a piece of tech that's free. It's very small. It can run in standalone or on, I usually run it on Tomcat, and that's what I'll be doing here. And you can put it in front of any database from 10G onwards, and you can turn the database, make the database REST enabled. If you've got Oracle 12c database, you've also got some additional options like this thing called Soda, which allows you to make an Oracle database look like a JSON document store, similar to CouchDB or MongoDB. It can also front Oracle's NoSQL solution, which I've not tried, so I'm not going to talk about that today and lie to you. Of course, it can still do all the things it used to do, like front PLSQL web toolkit applications like Apex. How does it do all of this? Well, what you've got is a situation where when a URI comes in, it's mapped to a database call. That's going to call some SQL or PLSQL. And depending on what's coming in, it may associate a payload or parameters in the URI with the parameters in the database call. It'll run whatever needs to be run on the database, and then we'll get results returned. If those results are a result set, it will convert them to JSON or CSV if you want to, although I wouldn't advise it. Notably not XML, and allegedly it will never do XML, so you can still do that manually, of course. But if it's a web toolkit application, like you're doing http.prints in there, then it will just push the output out for you, and you're totally responsible for what gets generated. So how do we get this working? Well, first thing we have to do is do enable schema. So once ORDS is installed on your app server, or even on the same machine as a database if you wanted to, although I wouldn't advise that, you connect it to the database and it will automatically install itself. Once it's installed, we can enable it for a specific schema by doing ords.enable schema, where you sort of say, yes, I want it enabled. This is the schema name I want to actually enable for ORDS, and I want to associate something with it. Now, in this case, I've associated something that looks like the schema name, but that's kind of ugly. Typically, you'd want to hide schema names with something that's going to look nice in a URI. So I'm going to jump to a demo now, and we'll see some of this, and then I'll race through the slides that accompany it because you'll have already seen it. So let's see if the demo is going to work for me today. Okay. So first thing I'm going to do is create a user called test user 2. And just give it create session and the ability to create a table. I'm going to create the emp table, so you'll be familiar with this if you're Oracle folks. Put in 14 rows of data, and that's what I'm going to enable for ORDS to present as web services. So what I do is ORDS enable schema, that thing I just talked about. I'm making test user 2 enabled, but giving it the URI HR. So what we're going to see is the base path /HR means that I'm really coming to this schema. What I'm then going to do is call enable object, say that I want to enable this object, test user 2 emp, tell it that it's a table, and say, I think emp is an ugly name, so I want to call it employees. Now what we've got at this point is that emp table I just built is now fully REST enabled. So let's have a look at what I get out of the box from this. If this is my base path, you'll see this in a moment. What I've got is my schema alias, and then I can do metadata catalog, and that will return a value, a JSON document listing all of the objects that are REST enabled in that schema. What we can see here is that call, curl, the URL, URI, sorry, and then I just pipe it to this little bit of Python to format it because it comes out minified and it's really hard to read. But what we can see here is I've got a single object in this schema that is enabled. I've got some links in there to the various, I can get the actual endpoint itself. I can get catalog information about that specific endpoint as opposed to the whole schema. And I can also get the Open API catalog for that as well. So let's have a look at the Open API catalog. So I'm now going to do the same sort of thing, but I'm going to call Open API catalog employees and get a description of the actual employees REST web service that's been auto-generated for me. So the same type of thing again. I'll just get to the top of that bad boy. Okay, so what I've got is ORDS, schema alias, API catalog, object alias, and then what I get out of it is I've got a description of the object. I should say what I'm doing here, because it's easier to demo, is I'm doing a host out to the OS and then doing curl. That's not because I have to, it's just because it makes timing my demo a bit easier. So this is just a curl command. It could be, in the case of a GET, it could be from a browser, or it could be from a reasonable web service tool like Postman or something like that. But what we get here is a description of all the data types that are involved in the table, and then a description of all of the columns and the data types that they are set to. And then we get a bunch of other stuff, including paths and the individual calls that we can make, like get, post, put, delete, along with the payloads that they're expecting. So that's all there. All I did was switch on a button and that's all there. So let's actually try and use something. So the first thing I'm going to do is use this URI, which is schema alias, object alias, and that's going to give me all of the employees in a JSON document. And sure enough, when I do that, I have, let's get to the top of the list, I have that curl command and I get a list of items. You can see that I've got 14 in total, one for each row. And in this JSON array, I've got each item defined with its data and the URI to get back to that specific item, so I don't have to get the full list. So that's all there, really easy to do. I haven't had to do any work. I can just get the individual employee by adding that, using that link with the individual ID on it. So I call that using / and the primary key, and I get the data and the links to the individual things, including how to get there and also how to get the catalog information. So remember, I've done nothing. I've just flicked a switch and I've got this out of the box. What I'm going to do now is some inserts, updates, and deletes. In order to do that, I need a payload, so I'm putting those in files, and I've got them prepared already. What we can see here is I'm just doing a cat of a file that exists on the file system called insert payload, and I've got a payload which is just a JSON document with name-value pairs representing each of the parameters that I want to, each of the columns in the table that will be treated as parameters. So if I run that, what I can see is I've now made a post rather than a get. A get is the default in curl, and your browsers do a get. I've done a HTTP post, passing in the raw payload of that file. I've set the content type to application JSON, and there's the URI that I'm going to. And what it's done is it's inserted that row into the database, and it's sent me back the output associated with that row in JSON format, along with all those nice links and all of that jazz. If I select from the table, I can see that user 9999 is now me, and I'm in department 10, although it's gone over the screen. Now what I can do is, if I just cat this other file, update payload, I can see that I'm now going to set employee 9999 to Wood with a department of 20. This time, same sort of call, except I've done a put, because remember, put is amend or create if it's not already present. And I've passed in the update payload, so a raw payload again with the data in it. It's sent out the data representing what I've just created. And if I select from the table, we can see that 9999 is now Wood and department 20 spanning the screen. Delete. Really easy as well. What I do is I've got my URI to employees, and then I've got a, wasn't expecting that. Then I've got a query indicator with some name value pairs in there. Now I can't actually do that from the command line because some of these, like, I'd have to be escaped. So I've got to put this nonsense with the character codes in, but believe me, those character codes equate to that. And then I can run that, and I've deleted the rows identified by that, which is a single row. We can see it's deleted a single row. And if I look back at my emp table, no rows in there. So remember, all I did was flick a switch, and I have fully REST enabled table. So that's as easy as ORDS can be, really. Now I've told you how easy it is. Don't ever do that. This is all the stuff I talked about. The important thing to remember is you have your endpoint. If as soon as I have my enable, it gives me an endpoint for the particular object, and that gives me get, put, post, and delete variations of the RESTful web services. But it's presenting a RESTful API over a table, and that's very rarely a good idea. If you think about how, for example, let's say we talk about creating an employee. It's rare that creating an employee is a single operation, like an insert. REST web services are all about... my brain is so terrible. Forget it. Okay, so when we're doing REST services, what you've got is that operation is stateless, that's the word. They're all about being stateless. So I call the web service, and that's done. It's over. There's no more work. There's no concept of session or anything in this. So if, for example, my creation of an employee is interacting with 5 tables, if I do them as 5 separate calls and something goes wrong, what do? I have to manually unpick all those pieces. I can't just do rollback because each call is complete and over. So it's important that you remember when you're doing RESTful web services, you should be treating them as stateless operations. So the entire operation has to be encompassed in a single call, if possible. And providing a RESTful API over many tables is probably not that. So I don't like that approach, even though it's available. What I would suggest is you would better do something yourself by presenting PLSQL APIs. On the surface, ORDS gives us something that looks like it could be interesting, which is auto PLSQL, where we do enable object again, but we can specify a procedure, function, or package in the same way. And what this will do is will give us an endpoint in a certain format for that procedure, function, or package. In the case of a procedural function, it's schema alias, object alias, so similar to what we saw before. In the case of package procedures or functions, what we get is schema alias, object alias, and then the routine name in uppercase, like so the package procedure or package function in uppercase, which is a little ugly. The other thing to remember about this is it is RPC. We don't get access to get, put, post, and delete. We only get access to post. So all of your endpoints have to say what they're doing, like delete employee, create employee. So it's not really a RESTful web service. But whether it's RESTful or not is just really preference, I guess, for some people. I like it. If you don't care, it doesn't matter, and this is useful. So although this is also incredibly easy, I would say don't use it. So how do I think you should be using it? Well, I think you should be presenting logical units of work, and we'll talk about how you do that now. So this is probably the simplest example I can give you of manually creating a service, and it's pretty dumb, but bear with me. So what we've got here is we're using define service to do everything in one go, and we're defining a module with its base path, a pattern or a template with its base path, and then the actual handler that's associated with the HTTP method, in this case get, and I've set the source type to query, and I've associated it with a query. So it's really simple and probably worse than using auto-REST. But what we have now is a web service defined with those three pieces. And so what I've got is my, in this case, I've got a separate database identifier in there. But what I've got is my schema alias, my module, my pattern or template, and then I define what's got to happen on this using the HTTP method. And we'll see some examples of that. And if I were to run that, I just get this sort of stuff out, which is a bit ugly. But as we saw in the, if I pretty it, it's just a list of items that look a little bit like that. So it's similar to what we saw in auto-REST. So we get no advantage there, but what we can do is start doing something a little bit more interesting. So for example, I can define a module separately using define module. Remember, the module holds multiple templates, one or more templates. I define the individual template /emp again, but now what I'm going to define the handler with is once again a query, but with some parameters in there. So what I can do now is actually access that from the URI by specifying the parameters if I wanted to. I can also do what I think is the right thing, which is to actually start using PLSQL to define things. So this is a really simple example, and also in order to get it onto the screen, it's got to be super small. So I've done something a little silly. I've defined a stored procedure with an input parameter. And what this does is open a ref cursor. If the parameter is present, it uses it. If not, it doesn't. And then I've got a little bit of JSON creation here using Apex JSON. So open object, convert my ref cursor to JSON using Apex JSON.write, and then close the object. So I'm doing all the JSON creation here. ORDS isn't doing anything. It's just acting as a gateway for me. What this allows me to do is now I can call this with two different modules. The first one, not passing in any parameters, and the second one, define a pattern with a parameter in as well, and pass that parameter into the procedure, which allows me two different ways of calling this. Give me all the data, give me the data for just this one. So at this point, this feels very similar to what you've seen in auto-REST, and I've purposely made it simple because I didn't want to have pages and pages of code. But the important thing to remember is whatever you can define in PLSQL, you can push through the gateway. So that could be your own JSON that you've generated. It could be XML. It could be images, whatever you want, because REST is not just about text files. It's about binaries as well. And there's an example on my website of pushing images out of this, which is really easy. So how do we start thinking about getting JSON in and out of the database, or specifically into the database in a kind of real way? Well, It's similar to what we've seen before, except now I'm defining handlers based on put, post and delete. So in this case, I want to create an employee. I don't want to do an insert. In this case, it's simple, but I've got a PL/SQL API. Each of these are individual parameters going in, but if this were a really complex document, I probably wouldn't be able to strip it apart like this. I'd probably pass it in as a single parameter, which is a blob, and then use the PL/SQL on the inside to shred it apart into its constituent pieces, and we'll see how to do that later. So in this case, this post handler calls create employee. This put handler calls amend employee. And this delete handler calls remove employee. So really simple, just calling stored procedures that do all the hard work. But now these are defined in a web service, I'm able to access all of that stored PL/SQL code from a REST API. So how would I call that? Well, in the example I'm going to show you of a post, what I need is my URI. I've got a post HTTP method. I need to pass in the content type of application JSON, and I need a raw payload that has all of the parameters that I need, or if this were a complex document, I'd just pass the whole document as one single big parameter, which is a blob. So let's have a look at an example of calling it. Well, you've seen this kind of thing already. Curl -x saying that I want to do a post. The binary data saying it's a raw payload and that you can find this raw payload in this file. Content type, application JSON, and then my actual URI to it. And it's as simple as that. And as I said before, this could be done from a a form in a HTML page, or it's better really if you use something like Postman or curl so you don't get browser caching issues. So really simple to create your own web services, and they're really, it's up to you how creative you want to be. But like I say, I like logical units of work. There's some new functionality that came out in, well, it was 17.3 beta of ORDS. It came out for GA at 17.4, but now we're at 18.1. So if you get the latest version of ORDS, you'll have this. What this allows you to do is, once you enable a schema, you can actually pass anything across to it and utilize the the SQL engine that's built into ORDS. So just the way that SQL-CL and SQL Developer have got an SQL engine, a PL/SQL engine in there, you can actually utilize the one in ORDS directly. What this means is you don't actually have to define anything to use a RESTful web service against that schema and do things like select statements or DML, DDL, anonymous block scripts. I'm not suggesting this is your REST solution for the database, but it's really good from an automation perspective. And there's some functionality in the latest release of Apex 18.1 that can make use of this, which is really handy because it saves you having database links everywhere. So pretty cool, but don't rely on it for your normal programming. The last thing you want is your application full of select statements being passed over REST web services. That's ugly as hell and really hard to do any sort of CRUD analysis on. So let's talk about JSON support in the database. And what we got is a story of, well, I suppose 2.5 parts really. 12.1 gave us consumption of JSON, 12.2 gave us production of JSON and alternatives for consumption, and then 18C gave us a bunch of nice to haves. So let's quickly run through some of these. 12.1, what we got is some new conditions and some new functions that allow us to look at JSON, store JSON in the database, but also look at the contents of it. And this thing called Soda, which I'm not going to talk about now because it's like mimicking something like MongoDB. So let's have a look at some of these things. The first thing to note is that Oracle doesn't use a new data type in order to store JSON. It just stores it in either a blob, a clob, or a varchar, or nvarchar, nclob, whatever you want. But we have this check constraint. So we can do check column name is JSON. And what that will do is validate that the contents is JSON. If you try and insert anything that isn't valid JSON, it will freak and give you an error message. We can also put the strict tag there, which means that it will test for strict JSON, so we can't have silly things like hanging commas and ugly stuff like that. So that's there to allow you to enforce the fact that the column contains JSON. It can also be used in a query, so I can say select from table where column is JSON, and it will only return the rows where that particular column contains JSON as opposed to non-JSON data. But of course, if the check constraint is on, it can only be null or JSON. Once this is in place, it's quite handy because it allows us to get to the data really easily. So we can do things like this, which is dot notation. So I can do table alias column name dot contact details dot phone, and that's actually traversed into the JSON document. That's only possible in 12.2, 12.1 and 12.2 if I have that constraint. There is a way to do it in 18C that's without the constraint, but that's kind of not really that relevant. What we have, first function I'm going to talk about is this one called JSON exists. And what JSON exists does is tells us if the element is actually present in the document. Because the weird thing about some of this stuff is if I check to see what a value is in the document, I get the same result, null being passed out, if the element is present but has no value, or if the element doesn't even exist in the document. So JSON exists is a way of checking that the element actually does exist in the document. And in this case, what I've done is said, I want the rows where the element phone exists, but the element phone is null. So the tag is there, the element is there, but it has a null value, and I get that out. That's all that does. JSON value allows us to return simple values out of a JSON document. So I can say something like, for example, the column name that holds the JSON and a JSON expression that equates to the data I'm interested in, and I get the simple value out. It can't get complex values like JSON objects out, just simple ones. If I need to return a JSON, something more complex like a JSON object or a JSON array, then I can use JSON query to do that. That's one option. In this case, notice I'm looking for the whole of contact details, not contact details.phone or something like that. And what it's done is it's returned me a whole fragment. So I can pull out individual elements with dot notation, JSON value, or JSON query, but I can also pull out complex fragments with JSON query. What I also got is a thing that's pretty neat. That has anyone done SQL XML before? Yeah, so I've used XML table before. Okay, so this is the JSON equivalent of XML table. So what we're doing is projecting columns over the JSON data to make it look like it's relational data. And we can do some quite clever stuff like nesting and stuff like that as well. It doesn't have to be a simple JSON document. But in this case, I've done a simple one. I've got first name, last name, date of birth, and those relate to these elements here. And then I've selected from this the alias associated with this JSON table to get the individual elements out. The important thing about this is that if you are going to start using a document store or store JSON, you can present everything really easily as relational type data. So it gives you the best of both worlds. In 18C, this is even easier because assuming I'm happy with these actual names, I can just list the names in here and I don't have to do any other definitions. It's got really simple. There's also a thing called JSON text contains. This is the syntax for a JSON search index in 12.1. In 12.2, it's much simpler, but for some reason I haven't bothered changing it yet. What we do if we create that JSON search index is we're able to use JSON contains to return data where we have a slightly fuzzier match. So this is like a full text index, and it means we can actually get better performance from searching our document store than if it were just full table scans of huge things, huge data stores. In 12.2, we got a whole bunch of new stuff. All of the JSON stuff got moved into its own manual. We also got the SQL Jason support for generating data from SQL directly. So similar to SQL XML, we have that here. The JSON conditions I mentioned here became native in PLSQL. In 12.1, you could only use them from SQL. We also got some new objects for generating and parsing data in 12c, which are like a replacement for Apex JSON. We got a thing called data guide, and unfortunately I won't have time to demo this, but this is really nice because what you can do with a data guide is just say, if you've got a JSON search index, the database will automatically look at the structure inside your JSON documents and allow you to do things like create views or create virtual columns based on the structure in there. So without even understanding JSON, you can query the data really easy. It's pretty cool. So let's have a look at a few of these bits. What we've got first of all is some of these SQL Jason functions. So first of all, JSON object, I have a comma separated list of name value pairs where the key is an arbitrary bit of text I want to put in, and the value can be also just a scalar, or it can be a column, or whatever I want. It can also be another function call, which we'll get on to in a minute. And what I get from that is a JSON object defined for each row in the table that matches the criteria containing the name value pairs as we've requested them. So pretty simple. We have JSON object ag, which aggregates JSON objects. So I've got a name value pair, and that's what I get out. One JSON object with all those elements aggregated into it. We've got JSON Array, which not surprisingly has a list of things, it comma separated, and it will generate an array containing those. Each one of these things can be different, so you can see I've got like even things that aren't particularly nice JSON. So that's pretty simple. We also have JSON Array Ag, which allows us to aggregate whatever we pass in. So in this case, employee name, and I get an aggregate, a JSON array aggregated out of that. Individually, they look a bit stupid because they don't seem to do very much. If you've used SQL XML before, you'll understand what's coming next, because the power of this comes from nesting these calls, because every time you see a value in any of these calls, that value can be another function call. So what we get is something like this. Don't worry if you can't read it, but you know the department list I showed you that contains the employees for every department actually within the tag? Well, that's how you can generate it from a single query. So we've got a JSON object of departments containing an array. Each array is its own department, which has a JSON object, which is basically a JSON object with some department data, and then a tag called employees, that the value of that is an array aggregate, and each one element of the array aggregates is a JSON object with the employee details in. So in a single query, I get that nested structure out. And if you've used SQL XML before, you'll understand why this is pretty neat. So that's kind of what we got in 12.1 and 12.2. In 18c, I've only recently gone through and written a lot of the functionality, but we got a bunch of extra stuff, but it's mostly nice to haves. This was the main body of what we got in 18c, in 12c. Just to have a quick look at the PLSQL side of things. Prior to 12.2, I did a lot of my PLSQL generation and parsing with Apex JSON, because it's a really neat package. You could also use PLJSON, I think was the one from Alexandria Library, but I used Apex JSON. This is effectively a replacement for that. So here's an example where I pass in a clob, I generate a JSON object from that clob, and then I pull out the array of departments. I loop through that array, and for each department I pull out individual bits of department data and the array of employees. 5 minutes, okay. And then I go through that loop of employees, pulling out the individual bits of JSON data from that. So if I wanted to, I could manually parse the JSON, but I could also create JSON using these PLSQL objects that were new in 12.2. So pretty neat, and when you first start using them, you'll probably hate them, because I did, because I was so used to Apex JSON, but when you get used to them, they're actually pretty nice. So that's kind of what we've got available in 12.2. So some quick mentions. If you're on 12.2, if you're on a version prior to 12.2, I always try and install Apex into my databases, because Apex comes with a bunch of stuff that's quite neat, even if you don't care about Apex itself. So calling out to web services with Apex Web Service, or parsing JSON text using Apex JSON is really neat to have. If you're on 12.2, then you don't really need to have it there, but it's still pretty nice anyway, because Apex is cool. It also does give you that ability to call out to web services, and that can be SOAP web services or REST web services, XML or JSON, it doesn't matter. Auto REST is very compelling because it means you can very quickly get stuff out of the door and make yourself feel cool. But I'd really try and avoid it if possible. If you're a shop that is almost entirely based around not the Oracle database, for example, you've got a whole bunch of developers who are Java or JSON developers and absolutely don't want to code any PLSQL, well, fine, REST enable all the tables and let them do their thing. But if you have got skills at PLSQL in-house, I would definitely suggest presenting out useful objects to the world rather than individual tables, and it will perform a lot better as well. I've not mentioned authentication here at all, but ORDS has several flows for authentication. You've got first-party authentication or basic authentication that can be done using a file-based repository in ORDS, which is not supported, but it can also use the WebLogic or Tomcat users for that. You can, in 18.1, you can actually do database authentication as well, but they don't really document that very well because they don't want you to use it. So I've got an article on my website that shows you how to use it, but I had to go to the developers in order to find out some of the pieces of that because it isn't really documented. There's also, but the main thing is it's got OAuth 2 flows. So it's got three-legged, two-legged, and implicit three-legged OAuth flows. So that's presumably how most people are doing their web service authentication these days, because it's a lot better than basic authentication. And it's also built into SQL Developer. So although I tend to do everything with the command line because I'm really old, if you don't like doing things with the command line, you can do it through SQL Developer or even through Apex. When you're in Apex, you have the option to do the old Apex style REST web services, which you shouldn't do, but you also have the option to use Apex as a front end for ORDS RESTful web services. So you can do those. So pretty cool. So what I would say to you is, if you're part of the old world order like me, the only way you can make yourself relevant is to make sure you present your skills out to the world in a form that they want to use. I don't know any developer that if you say, look, I've done half of your job for you, do you want to use this? Wouldn't say, yes, please. But then when it comes with the caveat of you've got to install all of this crap on your machine before you can call my stored procedure, you'll often get some pushback. Whereas if you're saying, here's a bunch of RESTful web services that are awesome, use them, happy days. I'm not saying this is the best solution for RESTful web services, but it is a solution, and it's a good one to pick if your skill set is predominantly Oracle based. So I have that website that I mentioned before, oraclebase.com. On there, there's a very simple page which is, this talk has actually got two names depending on where I'm presenting it. So this one here has got the PDF, the slides themselves, an article, and there's a couple of bits of stuff on YouTube, but I'm really lazy with YouTube these days. I just do the odd travel video. But the important thing is it's got a link through to this article which talks about a whole bunch of stuff that I've talked about here today. But more importantly, it has links through to all of the JSON and ORDS articles that I've got. So you can see there's a whole bunch of ORDS articles, and that's growing all the time. As I get to try different things or people ask me questions, I write an article about it. So If you go to the front page of the website, you'll get quick links to ORDS and JSON articles, which will give you everything you need to know, really. If you want the slides, they're there, oraclebase.com/workshops, but I think the articles probably make a bit more sense. So does anyone have any questions? Apart from, where's the food? I don't know where the food is, I'm sorry. So, question?
Hello.
Hi.
Do you know this ORDS also works with HTTP2 protocol or just only HTTP?
You know what? I absolutely don't know that. No, I don't know the answer to that, I'm afraid. I can ask it though. So I'll ping them a message to see if it does. Part of me thinks that maybe it depends on what you're actually surfacing it with, like whether it's being surfaced with sort of WebLogic or Tomcat or whatever. But then again, maybe there's a constraint under the hood for that. So I've certainly never used it with HTTP2. But then if you think about the nature of what it's doing, typically it's a call where you're asking for a synchronous give me this, and you're getting back a single thing. So I'm not sure. The advantage of, as I understand it, of HTTP2 is that you can make multiple requests simultaneously and get loads of stuff back from what appears to be a single call, like a web page can return loads of stuff simultaneously. And I'm not sure that's necessarily relevant for this, but I could be convinced otherwise. I'll ask the question though, because I'll DM the folks who write it and get their input on it. But good question. And I'll probably put the answer in my blog post tonight if I get a response from them. Anything else? Yep. Is this something else I won't understand?
Yes, again. What about authentication? For example, is it possible to authenticate client with certificates, client certificates, something like that?
When you say client certificates, what are we? We're not talking about HTTPS. You're talking about authentication. Yeah. So with the authentication, what the options we've got, I've actually got an article on it which will list all the options that are available at the moment. And there's another one I'm investigating at the moment, which I think might work, but I can't confirm that. So if we go down to authentication, what you can see here is the options we've got for basic authentication, which you probably shouldn't be using, but what they've kind of thrown their hand in on is OAuth 2. So typically what you'll do is you'll create, if we look at an individual flow, you can create roles and privileges in ORDS. So these aren't database roles and privileges, they're specific to ORDS. And then you can assign those to a different authentication method. So for example, here I've got an example of creating a client. The client gives me a client ID and a secret. I can then use those in the OAuth 2 flows in order to authenticate, maybe get an authentication token back and keep using that and even refresh it if it gets like old. So these are pretty standard OAuth 2 flows, and there's 3 different types it's got. So if that's what you mean, then yes. If you mean something other than that, then the answer is probably no. Does that answer your question? So come and speak to me at the end if you want. Yes?
So I wanted to ask you about the performance. You got all that cool stuff about parsing the JSON data and this, but it's not the relation tables anymore. Do you maybe have any complaints from the Oracle users about performance?
So if we're talking specifically about storing JSON in the database,
storing and then running some jobs on it, reports and.
I mean, I've spent 23 years doing this, so my hat is very much in the relational camp. I tend not to store JSON in the database. I tend to shred it and store it as relational information if possible. But I understand if people have a different requirement. For example, you don't really know what you're getting until it turns up, then you can't necessarily know how to shred it. So that's why you'd probably want to use a document store for something, or something that gradually changes over time in a semi-controlled manner. Then maybe a document store is more appropriate. You're always going to do extra work when you're having to strip this stuff apart. And although JSON indexes, search indexes can improve the performance, there is still a lot more work happening. So it's hard not to sound negative, but if you wanted to use a JSON document store, if that were your ultimate goal, why would you pick a relational database to do that? Because there are free things that don't cost lots of money. Please don't record that bit. That are probably going to work equally well, probably faster, and be free. The interesting use case comes from when you are predominantly relational and you want to have that crossover. So what you'll often find with document stores is they're great at doing what they do, and then someone says, can you get me all of the information where? And all of a sudden they get super hard to do those sort of cross-reporting things. Well, having that JSON in an Oracle database means that the cross-reporting is simple. In some cases, with the JSON data guide, you literally have to do nothing. It's just all done for you. So what I would say is it really depends on the use case. And if you've got that use case, the overhead of having it in a relational database, JSON stored in a relational database, is probably not a terrible thing. It's probably less of a problem than the overhead of trying to write SQL to run against something that doesn't understand what SQL is.
Okay, the bottom line is it depends.
Yeah, well, if Tom Kite taught us one thing, it's the answer to everything is it depends. What you'll normally find with large documents as well is performance will start to tail off the larger the document gets, just like we saw in the XML stuff. Storing XML in the database is great for small documents, but above a certain size, it grinds, and it's the same here because it's all a constraint on memory and processing at the end of the day. And the database was designed to do relational stuff, really, and these things are nice to haves on top of it. That is my opinion, not the opinion of Oracle Corporation. I do not work for them. Okay.